Okay, we are looking at telling whether you use a Z or a T test. And as you do the confidence intervals and as we go on to hypothesis tests, the first step is always going to be, what do I use? Do I use a Z or a T? And now some of them are obviously, if you have a proportion, you're always going to use a Z. As we learned a standard deviation, you're always going to use a chi, which we haven't got to. But means can go either way. You can either use a Z or a T. So how do you tell? And you can see that there's actually a third option here too, which is that neither apply. So how do we tell? Well, we look here and we see confidence interval is 95%. So this is always the information you want to pull out of your problem. They won't probably give it to you this basic, but that's the information you're looking to make a list of. What's the confidence interval we're looking for? In this case, 95%. What's our sample size? 23. We know our population standard deviation. How do we know this is population? Because it's a Greek letter. So if this is a Greek letter, whether we're talking mean, standard deviation, anything, if it's a Greek letter, it's the population. If it's an English letter, so it's an S or an X, then it is the sample statistic. So we know the population standard deviation, but the population appears to be very skewed. And you can see we have a small sample size. Therefore, neither is going to apply. Kind of skewed you look for, and then you've kind of got a problem, and you need to deal with that. And by the way, kind of coming back here for a second, I want to go back here for a second. This sample is under 30. 30 is kind of your benchmark. If it's over 30, you have more leeway. If it's under 30, you don't. So since it's under 30, then this skewed, you need a normally distributed population. Okay, so we've got another one here. So we want to know Z, T, or neither. So we have a 99% confidence interval now. Our sample is 300, so nice and large, so we're over a 30, so that means the skewed here doesn't matter anymore. That's okay. We can do this even though it's skewed because we're over 30, well over 30. And we know the sample, we know the population standard deviation because we've got a Greek letter here. This means this is a Z. So that's the big kicker. If you know the population standard deviation, so you have a Greek letter sitting there, you're going to use the Z. If you only have sample stuff, so it's an S here, for instance, and you don't know the population standard deviation, then you have to use the T. So the T is for when you don't know the population standard deviation. The Z is for when you do. So that's really what you're looking for. Obviously, the other stuff helps you make a decision of if you can go forward. But the main kicker, whether you're deciding, once you decide I can do this, I'm either normal or I'm over 30, then you're looking, okay, do I know the population standard deviation? If the answer is yes, I'm going to go use the Z. If the answer is no, I'm going to use the T. So in this case, we know a Z, so that means it's A or D. 99%, which means in our two tails we have 1.01 or 1% left. We cut that in half because half's in each. So that means we have 0.025 in each. And so that's, no, actually, here, sometimes you just gotta, I think I've got one. It hasn't been my morning for doing 0.005. That's what I get for sometimes doing math in my head. So 0.005, and you can see that's marked right here, 2.55. I was thinking it wasn't large enough right there. And you can see actually some ones are so common, they're down here. And these are the ones that you're going to see a lot of. Okay, let's see here. Now we have another one. Z or T, okay, we have a confidence interval of 99%. Okay, we're under 30, but we're normally distributed, so we're good. We can keep going through. And we know the population standard deviation, so we are still working with Z. Again, 99%, so this is going to be the same value as last time. Now let's go back up here. Let me see if I guessed the right number. And let's go one more. I think this is one like you just did. No, that's not what I want. Okay, here we go. So we've got a critical Z. Do we want a Z, T, or normal? We have a confidence interval of 99%. Our N is 22. Okay. It's pretty small, but we're normally distributed. We're okay. We can keep going. We don't know the population standard deviation. You can see here is unknown. This means we want a T test. So we have 99%, so that means we have 0.01 in 2 tails. Now, when you use the table for the t-table, you can see here we need to know 2 things. We need to know this. So area in 2 tails, we're in this area, and it's 0.01, so we're in this column, this first column. And then we have 22, which means our DF is -1, so 21. So I'm going to go down here in 21, and my T is 2.831. So this is my T-score. So as you work in this section, your first question is always going to be, do I do the Z or the T test? Well, really, your first question is, can I do it? And that's, do you have a large enough population, or is it normally distributed? Then once you're in there, do I do the Z or the T? And it's going to come down again and again to, do you know the population standard deviation? So that's what you want to really look for. Have they told me that? And remember, how you tell the difference is population is done in the Greek letters. Sample is done in just regular old plain English letters. So that's how you tell which one is. If they don't clearly say this is the population, they're going to use the right. That's the reason we have the different set of variables for each one, so that we can tell them apart.